Introduction, Materials, and Procedure. Your students will connect a positive and a negative electrode from a voltage source to a piece of conducting paper. An electric field will be generated on the conducting paper between these two electrodes. They will then find the equipotential lines by using a multimeter to find several points where the voltage is constant. That's what an equipotential line is. The voltage is the same on the line. And then connect those points. They will then draw electric field lines which will be perpendicular to the equipotential lines. It's suggested that students find the equipotential lines at a minimum for the two configurations below. So you can see right here, this is one electrode, let's call that the positive one. And this one will be the negative one. That's like 2-point charges, and you have to have opposite charge there, of course. Or a uniform electric field, which is generated by simulated two parallel plates. So your electric field will be in that direction, right? Assuming that this would be the positive and this would be the negative. This lab is designed to work with the PASCO Field Mapper Kit, as shown over here, and there'll be similar setups from different companies. And this one includes conducting paper, conducting pen, corkboards, pins, connecting wires, a digital multimeter, a battery, and graphing paper that matches the grid on the conducting paper. Now let's see, I'm pretty sure these are not coming with this particular kit. So whatever you don't have in the kit, make sure you get. Before the students arrive, you should make sure that you have functional multimeters and then check that the voltage of each 12-volt battery is at or above 11 volts using a multimeter. And frequently these are powered by 9-volt batteries. Make photocopies of a blank piece of the conducting paper if you don't already have graph paper that matches the conducting paper grid. Using the conductive pen, draw the configurations that students will test. They will also need some time to dry. If you're recycling conductive paper from a prior year, test taking measurements with each paper as they lose their effectiveness over time. If you don't have a conductive pen, use conductive bars, and this will make more sense if you have one of the commercially available setups. The conductive pens have a very short lifetime once opened, and they typically won't last until the next year. So draw the configurations you need shortly after opening a pen. Have the following items ready to go: the corkboards, conductive paper, pens, pins, batteries, and multimeters at every lab bench. Make sure your students know how to use the multimeter before the lab. You don't want to waste time during the lab training them. Do that ahead of time. And emphasize to students that the batteries terminal should never be connected directly to each other. This can heat the wire very rapidly and pose a safety risk. You could even catch a piece of paper on fire if it touches that wire, so be very careful. Put the conductive paper with the electrode configurations on a corkboard and place a pin on each side. Make sure you stick the pins on the electrode drawings at each point and press the pins down tight. So it looks like over here we're going to use the two parallel lines for uniform electric field. Your pin should be right here and right here, and make sure that's tightly through the conductive paper. Next step, we have our pin here, one pin here and the other pin here. So what we want to do is connect the battery to that, and we're going to connect this side. This will be our common, this will be the black one. So black wire, and that'll connect to the negative terminal of the battery. And then to the positive terminal of the battery, you connect a red wire and connect it right to that pin, and there's your negative pin. You will then use your voltmeter and take the common from your voltmeter and put it over here on the negative side of your circuit here, on the common side. Then you'll use your other probe, the red one, and you'll be moving this one between your two electrodes. And you will be finding equipotential lines by moving the pin to locations where the voltage does not change. So again, black is on this side, red is this side. This wire stays fixed the whole time, this lead from the voltmeter or your multimeter to your negative side of your setup here. And the red one is the one you'll be moving around in here to find equal voltages. Find at least 6 equipotential lines per electrode configuration. Label the voltages on the graph paper that match the grid on the electrode. Then draw the resulting equipotential lines on the graph paper. So what you have here, here's your experimental setup where you're moving the probe, right, the red side of your multimeter, to various places. Let's say here's your configuration here. You have 2 parallel planes. You'll be moving this probe to find equipotential lines. The grid has, well, it's a grid, so it has different numbers on it. Tells you how many centimeters you are away from the edges. And what you're going to do is on the side have your graph paper or a photocopy of this. And if you find an equipotential line, let's say you find it there, you'll just go ahead and draw it here on your graph paper or the photocopy of what the conductive paper looks like. So experiment here and then draw what you see over here on the paper. Warnings and tips. Be sure that the pins are not longer than the cork board. You don't want them contacting anything below the cork board. The voltages may not be exactly as you expect. The battery will probably not be a full 12 volts. Imperfect conductors or loose connections cause this disparity, or the battery's getting old. Advise students to not connect the electrodes to each other and the battery. This may cause sparks and possible electric shock, or if the sparks hit a piece of paper, you could set that on fire. Not good. Set the multimeter to measure volts on the 20 volt setting. Now, each multimeter will be different, so use an equally appropriate measurement scale. We have a 12 volt battery, so you're not going to set it for 100 volts, and you're equally not going to set it for 2 volts. You will peg the meter, it will get too high. Do not set the multimeter to measure current. That can damage the multimeter with the setup we have. Be sure it's on voltage. Make a firm connection between the wires from the battery and the pins attached to the electrodes on the conductive paper. You don't want any connections coming loose. Start the data collection by finding the voltage halfway down the paper near one of the electrodes. Move the free multimeter probe, that's the red one, and find a voltage. Label the voltage at that location. And again, we'll be labeling it on your separate sheet of non-conductive paper, which is either a photocopy of the conductive paper or graph paper. Move up and down from that point, searching for additional locations where you have the same voltage. Label each point. Find enough points so you can draw a line through for the entire height of the paper. So here's your paper here. You want to make sure you get points like that. Well, not specifically like that, but from the top to the bottom. Then connect those points as an equipotential line. Once you have one equipotential line, move the free probe, the red line, the red wire, to find a different voltage. Then repeat steps 1 through 3. Use the same difference in potential between equipotential lines. So if the first one is, let's say, 5 volts, you want to find a location maybe where it's 4 volts, and then 3 volts, and so on. You need a minimum of 6. So actually, would 5 do? Nope, you'd have to start at least 6 volts. Sketch in the electric field between the electrodes. Label the electric field lines. And the electric field lines will be perpendicular to your equipotential lines. So you've done it for one configuration. Maybe you did it for the 2 point charges. So the next one, do the 2 parallel plates. Or if you did the 2 parallel plates, then do it for the 2 point charges of opposite polarity. Listening to a procedure can only go so far, so please click on this and see what this looks like when you do it for real.